The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are two different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmail@ybcc.edu and I will respond as soon as I can. All right, we're going to go on to section 5.7, but first, I had a question from 5.6, so let's take a look at that. This is problem number 28 from 5.6, and it talks about the slope of the x-axis. This is a concept that comes from Math 85, the previous course. We haven't talked about that this quarter, but the idea of slope is rise over run, or perhaps fall over run. So going from left to right, it's going to go up or down, positive or negative, and then to the right. Take a look at line number 1, this blue line, okay? Our scale, every big square is 1 unit. So this goes up 1 as it goes over 1. So the slope would be 1 over 1, or we would just say the slope equals 1. Take a look at line 2. Line 2 goes up or down an infinite amount, but it has no run. It's like a number divided by 0, which would be undefined. So a vertical line has a slope that is undefined. Line number 3 has a negative slope. It goes down. Let's see, if we go from this point to this point, it goes down 2 as it goes over 3. So the slope would be negative 2/3. But now the question says, what is the slope of the x-axis? The x-axis would be this right here. That has no rise or fall, so it would be 0 over some non-zero number. Well, let's go from this point, let's say, to this point. So we'd go 0 up or down over 2. 0 over 2 is just 0. So the slope of a horizontal line is 0. All right, any questions about that before we go on? Okay. So now we're going to go on to section 5.7. And yesterday, we looked at multiplying polynomials together and getting a resulting polynomial. Today, we're also going to be multiplying polynomials together. This is called special products. We're going to look at some special situations that happen. And I want to start out with this situation. Let's say we have the quantity y plus 7 squared, okay? I actually want to go back in this chapter to some rules that we didn't specifically cover. Again, they're sort of a review from a previous chapter or previous course. But let's say we had 2a, the quantity cubed. So we have a product raised to a power. We end up attaching that outside exponent to each factor inside. So ultimately we end up with 8a cubed. But let's say we have 2 plus a squared. That is not equal to 2 squared plus a squared. It doesn't work that way. What does happen, whoops, if we have 2 plus a, the quantity squared, we have 2 plus a times 2 plus a. We have 2 factors of that base. And then we FOIL them together, like in the last section. So we get 4 plus 2a plus 2a plus a squared, or a squared plus 4a plus 4, which is quite different from what you'd get if you did it incorrectly. You'd get 4 plus a squared. So we need to be careful that we don't take a situation where we have a sum or a difference inside parentheses raised to a power, that we don't take it and treat it like a product raised to a power. So back to the original problem, y plus 7, the quantity squared. The next step is going to be y plus 7 times y plus 7. I have two factors of that base. Then I'm going to multiply the two factors together. So I get y times y is y squared. Y times 7 is 7y. 7 times y is 7y. 7 times 7 is 49. So I get y squared plus 14y plus 49. This is what's known as a perfect square trinomial. Well, let's take a look at what a perfect square is. 0 times 0 equals 0, 1 times 1 equals 1, 2 times 2 equals 4, 3 times 3 equals 9, 4 times 4 equals 16, etc., etc. These numbers, 0, 1, 4, 9, 16, 25, 36, 49, 64, etc., etc., are called perfect squares because they have two identical factors. So back to this problem, this has two identical factors, y plus 7 and y plus 7. So it's known as a perfect square trinomial. All right, let's take a look at some more examples of that. We have b minus 1, the quantity squared. So this becomes b minus 1 times b minus 1. Foiling it together, we get b squared minus 1b minus 1b plus 1, minus 1 times minus 1. Combining like terms, b squared minus 2b plus 1 is our final result, final product. Any questions there? All righty. Let's take a look at this problem. D plus 0.2, the quantity squared. So we get D plus 0.2 times D plus 0.2. We get D squared plus 0.2D plus 0.2D plus, careful now, 0.2 times 0.2, we'd have a 4, but we'd have to move over 2 places, so we'd get 0.04. All right? So then we get d squared plus 0.4d plus 0.04. Be careful adding, subtracting, multiplying, dividing decimals. Don't forget those rules. Okay, let's take a look at this one. C squared plus d squared, the quantity squared. So this is c squared plus d squared times c squared plus d squared. So we get c to the 4th power plus c squared d squared plus c squared d squared plus d to the 4th power, which is c squared plus 2 c squared d squared plus d to the 4th power. Notice something, and maybe I should have mentioned this before as a reminder. So here I had c squared times d squared. Here I had d squared times c squared, but instead of writing d squared, c squared, I put the variables in alphabetical order within the term so that it was easy to recognize that those were like terms. If I'd written the first one like this and the second one like that, you might not have seen that those are like terms. Okay, so be careful with that. Here's another example. Y minus 5/3, the quantity squared. So this is y minus 5/3 times y minus 5/3, which is going to be y squared minus 5/3 y minus 5/3 y plus, so negative 5/3 times negative 5/3 is going to be positive 25/9, because you multiply fractions straight across the numerators and then the denominators. So y squared minus 10/3 y plus 25/9 would be the final product. All right, so that's dealing with a situation where you've got two identical factors and you multiply them together. Now we're going to look at a completely different situation. Here, we're starting out with two factors that are not the same. They're not even opposites. The opposite of y plus 6 would be negative y minus 6, and that's not what we have here. These are called a conjugate pair. We have the sum of two numbers times the difference of the same two numbers in the same order. Let's see what happens when we FOIL these together. We get y squared minus 6y plus 6y minus 36. The two middle terms cancel each other out, and we're left with y squared minus 36. So we take a binomial times a binomial, but we get an answer that's also a binomial. So those two middle terms cancel each other out. This is always going to happen when you have this situation of a conjugate pair. Now, the answer to this, or the product of this, is called the difference of two squares. First of all, difference because it is a subtraction, so it's a difference. And then 2 because there's 1, 2. But if we look at y squared, we could write it as y, the quantity squared. And 36 could be written as 6, the quantity squared. So in fact, we have the difference of two squares. Notice that the base for this square and the base for this square are the two numbers that are being added and then subtracted. So there's a shortcut we could apply if we wanted to. For instance, x plus 3 times x minus 3 is going to be x squared minus 3 squared, or x squared minus 9. Doing it the long way, we could go like this and say x squared minus 3x plus 3x minus 9, x squared minus 9. But if you have a conjugate pair that you're multiplying together, you're going to get this pattern leading to this. And again, there's nothing wrong with doing it this way, but if you want to take the shortcut, there it is. All right, let's look at some more of these. Let's say I've got 5a plus 4 times 5a minus 4. So that's a conjugate pair. That's going to be 5a, the quantity squared, minus 4, the quantity squared. Now here, this is a product, so that would be 5 squared a squared, or 25a squared, minus 16. But again, if you don't feel comfortable doing that shortcut pattern, you could also go back and multiply it one at a time. 25a squared minus 20a plus 20a minus 16. Cancel the middle terms. 25a squared minus 16. All righty. Let's take a look at another situation. We have m plus 4/5 times m minus 4/5. So this is going to be m squared minus 4/5 squared, which would be m squared minus 16/25. Any questions how I got that? And as I mentioned before, you could FOIL it and cancel out the two middle terms and still arrive at the same answer. Now, let's say we have a binomial cube. So this would be what's known as a perfect cube. It has three identical factors. Again, this is not x cubed plus 4 cubed. Now we have to take x plus 4 times x plus 4 times x plus 4. We have three identical factors of x plus 4. We're only going to multiply two factors together at a time. So going from left to right, we'll do those first. So this becomes x squared plus 4x plus 4x plus 16. And then that result will get multiplied by the last factor. But I can simplify that first product further first. So x squared plus 8x plus 16 all times x plus 4. So now I've got x cubed minus, plus 4x squared plus 8x squared plus 32x plus 16x plus 64. Combining like terms, x cubed plus 12x squared plus 48x plus 64. So we get this huge polynomial. And again, it's not x cubed plus 4 cubed. It's x plus 4 times x plus 4 times x plus 4. Any questions about that situation? All right. Let's say we've got the quantity 3x minus 2 cubed. So that's going to be 3x minus 2 times 3x minus 2 times 3x minus 2. I'll multiply the first two together first. So I get 9x squared minus 6x minus 6x plus 4. All of that times the final factor of 3x minus 2. But simplifying inside that first product, we get 9x squared minus 12x plus 4 times 3x minus 2. Continuing to multiply, 27x cubed minus 18x squared minus 36x plus 24x plus 12x minus 8. Combining, oh, hang on, I think I might have done something wrong. Let's make sure. Let's see. 27x cubed minus 18x squared. I did right here. This should be minus 36x squared. I was suspicious because I had 3 terms with x and just 1 term with x squared. So I missed an exponent there. All right. 27x cubed minus what? 54x squared. I think I just need to slow down. Plus 36x minus 8. And let's see here. So we get another polynomial answer. All right. Now let's kind of mix things together a bit. Let's say we've got 2 times the quantity x squared plus 7x minus 1 minus 3 times the quantity x squared minus 2x plus 2. So we're going to start out order of operations, grouping symbols inside the parentheses. There's nothing we can do. There's no like terms or anything. So now I'm going to distribute, first of all, the 2x squared plus 14x minus 2. Then I'm going to distribute the minus 3. So this becomes minus 3x squared. Minus 3 times minus 2x would be plus 6x. And minus 3 times plus 2 would be minus 6. Now that I've done the multiplication, next would be the addition and subtraction from left to right. Combining like terms, these are going to go together, and those are going to go together, and those are going to go together. So 2x squared minus 3x squared would be negative x squared. It's negative 1x squared, but don't put the 1 there. It's not needed. And then 14x plus 6x would be plus 20x. Minus 2 minus 6 would be minus 8. Okay. Any questions there? All righty. Let's take a look at this example. 2t times t plus 2 plus t minus 1 times t plus 9. So again, order of operations, there's nothing in the parentheses that we can simplify within them. So we'll start by multiplying here, 2t squared plus 4t. Then we'll FOIL these last two binomials together, t squared plus 9t minus 1t minus 9. And that's going to be plus all of that. So 2t squared plus 4t. And then plus, let's see, what do I get? T squared plus 8t minus 9. So now I've got 3t squared plus 12t minus 9. And there's my final result. Okay. So we had multiplication, foiling, and then addition or subtraction, combining like terms in that problem. Let's take a look at this one. 5a minus 1, the quantity squared minus a minus 8 times a plus 8. All right, we've got to be really careful here. I'll explain as we get there. So first of all, I've got 5a minus 1 times 5a minus 1 minus the quantity a minus 8 times a plus 8. Okay. Foiling together the first two binomial factors, we get 25a squared minus 5a plus 1. Combining like terms, 25a squared minus 10a plus 1. Okay, so all of this becomes all of that. So far, so good. Now, let's take a look at this. That's going to be what? A squared minus 8 squared, which is a squared minus, not 16. A squared minus 64. But here's where we got to be really careful. We're subtracting this product. We're subtracting this product. We're subtracting this product. We're subtracting this product. We need to group that whole thing, a squared minus 64, because we're going to subtract that whole result. So in the next step, we're going to get 25a squared minus 10a plus 1 minus a squared plus 64. If I fail to group that a squared minus 64, when I'm not going to distribute the minus sign, I'm going to get minus a squared and then minus 64. But I've got to quantify that amount and subtract that whole thing. So be careful of that. Okay. The subtraction signs are the problem. All right, now combining the like terms, we've got 24a squared minus 10a plus 65. Okay, any questions there? Let's take a look at this situation. Negative 5d times 4d minus 1 squared. Before we do this problem, let's look at a different problem. Let's say we've got negative 3 times 2 squared. Okay, what do you do first? Do you take the 2 and you square it and get 4 and then take negative 3 times 4? Or do you take the negative 3 times 2 and get negative 6 and then square that first? So in other words, do you do the exponent or the regular multiplication first? Well, hopefully, go ahead. You going to answer?
The exponent?
Correct. We do the exponent first. So the same thing is true over here. We've got to do this exponent first. We're not going to take the negative 5d and distribute it through the 4d minus 1. Okay. We're going to get negative 5d and then what? 4d minus 1 times 4d minus 1. So we're going to do the exponent first. Now we have a choice. We can continue to FOIL that together and simplify it and then multiply by negative 5d. Or we could take negative 5d and multiply it here, but only times that first factor. For instance, if we took this and expanded it to that, and then we didn't multiply those together for next, we could do that, negative 6 times 2 and get negative 12. I'm going to go ahead and do this first, however, okay? But I have a choice here, but I don't have a choice up here. I've got to do the exponent first. So now I've got negative 5d, and then this is going to give me what? 16d squared minus 4d minus 4d plus 1, negative 5d times 16d squared minus 8d plus 1. So now that I've multiplied that out and simplified it, I'm going to distribute and get what? Negative 80d cubed plus 40d squared minus 5d. Okay. So be careful, order of operations, exponents before regular multiplication. And let's see here. How are we doing? Time. Okay. So let's say we've got this situation. 8x to the 4th minus 3 squared. That would be 8x to the 4th minus 3 times 8x to the 4th minus 3, which then becomes 64x to the 8th power minus 24x to the 4th power minus 24x to the 4th power plus 9, which then becomes 64x to the 8th minus 48x to the 4th plus 9. You've got to be careful with the rules, because here, when we're multiplying, x to the 4th times x to the 4th becomes x to the 8th. But here, when we're adding or subtracting, we've got so many x to the 4th minus so many more x to the 4th, so we're going to end up with a bunch of x to the 4th. So be careful you don't get those rules mixed up. Okay, let's see here. 4t plus 0.6 times 4t minus 0.6. So if I use the shortcut, this is the difference of two squares. So it's going to be that. 4t, the quantity squared, is 4 squared t squared, or 16t squared. 0.6 times 0.6 would be, let's see, 36, move over 2 places, so that would be 0.36, or minus 0.36. And again, you could do this by just regular FOIL if you don't want to apply the shortcut, if you're uncomfortable with that idea yet. Okay, let's see here. 3 times the quantity y minus 4 minus 5 times the quantity y plus 3. So we get 3y minus 12 minus 5y minus 15, combining like terms, negative 2y minus 27. Okay, let's take a look at this. I kind of touched on this a little bit before. these are some lookalikes problems. So they're similar, but yet not exact. And as I say, I kind of introduced something like this earlier. So on the left side, part A, we have a product raised to a power. So this becomes x squared y squared. On the right side, part B, we have a sum raised to a power. So that becomes x plus y times x plus y, which then becomes x squared plus xy plus xy plus y squared, x squared plus 2xy plus y squared. And the two answers are very different. So really make note of those differences. Okay. How about this one? Part A, we have mn cubed, and part B, m plus n cubed. So part A is m cubed, n cubed. That was nice. Part B, m plus n, m plus n, m plus n. This is going to take a bit more work. So doing the first two, we're going to get m squared plus mn plus mn plus n squared times the quantity m plus n. Combining like terms, m squared plus 2mn plus n squared times the quantity m plus n. Continuing to multiply, m cubed plus m squared n plus 2m squared n plus 2mn squared plus mn squared plus n cubed. I kind of ran out of room there. So let's see. Those are like terms and those are like terms. So I've got m cubed plus 3m squared n plus, let's see here, 3mn squared plus n cubed. So again, the point being that you get very different answers whether you've got a product raised to a power or a sum, or in fact a difference raised to a power. So be especially careful with that. Okay, let's see here. I think that's it for today. So I'll be back this afternoon at 1:15 if you have any questions. Otherwise, have a great rest of the day. I'm going to go ahead and stop the recording.